Thank you PCBWay for sponsoring another project video.
Alright guys, so welcome back. So once again, I want to thank PCBWay for sponsoring another project video for me. These guys have really been great. If I had known about these guys before I had gotten my 3D printer, I probably would have used them. I'm sure I would have used them to make all my rotors, because I used to make them out of acrylic and resin, and it was a real pain in the butt. But ever since I got hooked up with these guys, they've been making me some fantastic rotors. This is one of them. And I really like this clear acrylic resin that they do. Anyway, what I do too is and I don't do this to check their accuracy. I do this to make sure I don't send them a bad file. I'll 3D print the file before I send it to them to make sure that I didn't make any mistakes in the measurements, because the stuff they send back to me is always right on. It's in within 1/10 of a millimeter. So here's the latest one. Let me get this out of the package here. This thing came out gorgeous too. Look at that. That is beautiful. And it's the exact copy of this guy here. Yeah, it came out really nice. I mean, this is gorgeous. So I'm going to take the magnets out of this one, put it in this one, then I'll put it in a stand and we'll get it going. What I'm probably going to do is do a dual stand one with this guy too. This guy will be at the top, this guy will be in the middle, or something like that. But yeah, the magnets and the bearings are all press fit, because like I said, these guys get it within, at the most, 2/10 of a millimeter. It's usually around 1/10 of a millimeter, either larger or smaller, but I never have any issues. And I've gotten all kinds of great prints from these guys, some out of aluminum, stainless steel. So if you have a project and you don't have a 3D printer, or even if you have a 3D printer and you want to 3D print it in something other than PLA or PETG, give PCBWay a try. These guys do fantastic work. It's fast. They also do circuit boards. I think you get 5 for $10 or 10 for $5. Yeah, I think it's 10 for $5. I'm not really sure. I'll have to look that up and correct it in the description, because I don't get circuit boards from them, because I'm not really into that. I get all my 3D prints from them, and they also do sheet metal, CNC fabrication. They do all kinds of things. So anyway, let me get this guy. God, I really like the way this looks. Look at that center part there. I don't know if you can see it. That center part, that's the hole. That's why I like this clear acrylic. And I can't produce this with my 3D printer. I don't know how they do it. I think it's with an SLS or an SLA format. Then they do some kind of a spray varnish on there to give it this gorgeous sheen look to it. And I discovered it by accident. They had sent me, what did I do with it? They had sent me a PCBWay, I can't find it. I'll see if I can find it later. A PCBWay tchotchke that said PCBWay on it. And it was done in this material. And I asked my my contact there, I said, hey, is that something that you guys do, or did you do that in-house, or did you send out for it? How was that thing made? And they said, no, we do it here. And they showed me exactly how, and that's when I started doing these. Anyway, let me get this guy together, and I'll bring you guys back. Stay tuned. And just to correct what I said before, it's it's 10 PCBs for $5. And they're also running their 7th project design contest. So if you do anything electronically, they're also having a mechanical design category this year. So if you're a designer and you're doing anything creative and you want to get noticed or you want to enter the contest, just head over to PCBWay.com and you'll see it's splashed on their homepage. Their PCBWay 7th Project Design Contest. Anyway, I wanted to clear that up. And I cannot find, for the life of me, the thing they made for me that said PCBWay, and it was done in this material. Oh, I just press fitted the bearings in there, and they're press fit. They don't come out, which is fantastic. Anyway, stay tuned. Let me get some magnets in here. Oh, and really quick, this is the piece I was telling you guys about. So they had sent this to me, you know, like a tchotchke, and I think it was like the second or third time I I requested a rotor from them. And I was fascinated by, yeah, it was after I did the stainless steel rotor. I thought they probably didn't do this in-house. They probably did this, you know, with some company that just makes logos for them. But I asked, and they told me right away, you know, how they did it, and that's how I started doing these guys. So I got the magnets in there, and this thing works great. Let me slide it on top of here just to show you the, look at that, huh? Perfectly centered. So I'm going to put this guy in the center here, and then put this guy up top, and we'll see if we can get going with that. So stay tuned. All right, excuse me. So this is what I'm going to do. I'm going to use my new coil, the one that produced so much output voltage before. This is the newest PCB. Let me get this a little closer here. Yeah, this is the newest rotor with the see-through acrylic. This is one of the other ones they made for me too. This one's kind of cool. And then here's my stainless steel one. And here's the very first one, my aluminum rotor, which I was so thrilled because all these years I've been wanting to make an aluminum rotor, and PCBWay made it happen for me. I do have a casualty though, and it really pisses me off. I was stupid and I broke this guy. You can see it's broken. I could probably glue it, which I will, just so I can keep it. But this was the second to the last rotor these guys made for me, and I just recently screwed up. I tried to do something to it, and I don't know if you can see that crack there. Yeah, you can see that. I'm so bummed. Anyway, let me get the things hooked up. I'm probably going to put some coils up here, and maybe I'm going to run it from down here though, using this this bifilar coil. This is a nice one. I wish I did it by hand, but I didn't. I did it on the machine, so it didn't come out that good. But it still works. I either do it like this, or like this, or I'll do it like this. Probably like that. Anyway, let me get everything hooked up and I'll bring you guys back. Stay tuned. So it's working really good. I don't have anything hooked up in the top here. But this little coil, this little rotor with 12 volts coming in is pumping out 160 volt DC. I need to hook up my amp meter. I have two of them. I've got an amp and a milliamp. Let me hook up my milliamp and see what kind of amp. It's probably almost nothing, but that's all right. It's still cool. It's a nice little rotor. I can even stop this one and it'll still go crazy, but I do that for balance. I put the second one up there for balance, and also I can put a couple of coils up there. But yeah, 12.5 coming in, 160 going out through this full bridge rectifier here, right here. 161.3 VC. I mean DC. VC. It's working pretty nice, man. And I'm doing it on a single JL94 circuit that was made by Sky Collection. Nice. 163. Let me see if I can hook up the voltmeter correctly. So stay tuned. All right. So I forgot that this new Gotcha Fix meter has a milliamp reading. So according to this, 17.30 milliamps, which is not a lot. And I don't even know if I'm reading that correctly. That's what it says here anyway. So yeah, there's not a lot of amperage in this. It pumps out a lot of voltage, but not a lot of amps. I put it back to, yeah, 158 volts. Anyway, that's not why I'm really doing this. I'm doing this to see how well this little guy works. And he works really well. All right, let me see what else I can do. I've also got this big monster I want to hook up. This big guy here. So I'm going to hook him up next. Oops. I'm going to hook him up next. Come on, man. And see what's going there. So stay tuned. Just out of curiosity, I wanted to see what this big monster rotor here was going to get with about a 2-inch gap, which is a huge gap. And it's still going really well. I could hook this up using my dual JL94 circuit and really get this thing flying, but I just wanted to see. It's putting out about the same, 162, and if I change this over to the milliamp reading, 15.5260. If I click on the 10 milliamp, 3, I'm not really sure. I got to read how this works. Maybe one of you guys can tell me. So 17, or is that 170? No, 17 milliamps is not a lot. But I don't really care about that. And when it beeps like that, that means that it's overloading. But it still holds up. So let me get this other big boy on here and see what we can do. All right, stay tuned. All right, so this guy is a beast. So the first thing I'm going to do is try it with this one using a single circuit. So let me turn on the power and get it going. So the single circuit in this way takes a while for it to get going, but it is going, and it's producing 156 volts through the bridge rectifier. But what I really want to do is I want to get this guy on the dual JL94 circuit using one of Sky's, no, I guess I can use one of my coils. But yeah, it's a beast, but it's perfectly balanced. Nothing's shaking. Pretty nice, huh? It's a big ass rotor. If I were to stick my finger in there, ow, it would knock it out. I mean, it would hurt it. Yeah, it's producing 166 volts. Let's see what it's doing with the milliamp thing. 140 milliamps or 16.4. I don't really know how to read that stupid thing. Anyway, putting out a lot of back EMF too. You can see by this circuit right here. You can see the little little neon bulb there. This one doesn't have an output for it though, but the dual circuit does, the dual JL94. So let me get that hooked up because I'm really curious on how that's going to work. So stay tuned. Yeah, running the dual JL94 circuit on this puppy really puts out a lot of output. I've got to undo these lights because they're just too much. And it's got it flying. Let me turn it down a little bit. And this is a large coil with a big air core. But yeah, she's flying. Woo! You know, I could use one of K Energy's opto circuits on this. I might even try that. But I knew the JL94 circuit, the dual one, would really kick this thing into high gear. Let me turn it down a little bit. 10 volts. I wonder what the output is on one of these. Let me see if I could figure out which one is which. Let me see if I can do that. 19 volts, so 19, probably about 20 volts on each of these light outputs. I could run those in series, hook them up to the bridge rectifier, and really kick this thing into high gear. Woo! That is bright. I don't know if you guys can see that. Let me see. It's pulsating for you guys, but it's solid white for me. Really bright too. Holy crap! But yeah, that's a killer rotor, man. It's got a lot of momentum too. There's a huge flywheel effect going on because of the weight. Not so much, well, the PETG that I used, I only did like 15% infill. So there's not too much weight with the actual housing itself. It's the magnets on the end. And because there's 6 of them, yeah, it's flying good. Let me see what I can do as far as hooking up the bridge rectifier to this thing and seeing what kind of output we're really getting. All right, stay tuned. All right, so I got this puppy hooked up, and I have the output hooked up in parallel. So I'm getting 15 volts out just from the back EMF from the circuit. I think I got it hooked up right. I'm not going to worry about that. This thing is working really well, and that's only at 11 volts in. What I want to do is I want to try some different coils. I'm not going to worry so much about the output. I'm going to put the lights back on. So let me try some different coils, and I'll bring you guys right back. Stay tuned. All right, so I've got this killer sky coil in here. It's a curved coil. I think you guys can see it, right? Yeah. And only 11 volts coming in, and it is flying out. That is a really good coil. It's putting out a lot of power. The coil is. One of the outputs from the circuit's putting out 5 volts, not including what the light's doing. So it's probably like around 20 volts each, like I said before. Yeah, I have to figure out a better way for mounting the coils for this rig. There we go. I wanted to do it this way, but there was no way to do it. Let me turn that off. That's only 11 volts coming in. And it's funny because it's using 1, 2, 3, 4, 5, using 6 bearings. And it's using all of them. Because I can stop it like this, or I can let it go like this. It's using all of them. At least I think it is. Woo, that's a beast. And here is the coil that I had running. This coil I normally use for my maglev. You guys seen those? Well, if you haven't, you can go back and look at my video catalog. You'll see the maglev in there. I've had some great successes with it, and I also had some great failures with it. But anyway, let me get some more coils set up. Stay tuned. So this is the first coil I ever got from Sky. It's a pancake coil, and it's a good coil too. You can see. Wait a minute, let me fix this. There you go. You guys can see that now, right? Yeah. Only a little bit of voltage coming in. 11 volts. Let's turn it up a little bit. $16 volts. No, I don't want to do that. Let's keep it at around 12. Damn, I like that rotor. It's working really good. A lot of back EMF because the neons are glowing and the lights are glowing, or the lights are going off. The neons are glowing. It's only putting out 4 volts to this side after the light, that is. I'm going to have to hook this up to my SuperCat bank. This bad boy. I 3D printed this housing for it. It didn't come out very good. I did this years ago when I had my Ender 3 Pro. I think I'm going to do a new one though, because it slides right out like that. I'm going to charge this up using this and see what we can get going here. Stay tuned. And then I'm going to run this using this, but I'm going to try some more coils, so hold on. So this is an old bifilar coil that I made, and I made it so it would take this iron powdered fill core, but there's not a lot of iron in here. If I take a magnet and show you, let me get a magnet. Oh God, these magnets are so strong. It sticks to it. Oh yeah, I guess it's pretty good. I should probably try and put it in there, because it's not in there right now. And there's no reason to put it in there because I have nothing hooked up to the output. I have nothing hooked up to the output other than the meter on this one light, which I'm going to take off because it's stupid. Take that off. But it works pretty good. I've never had a lot of luck with this one coil. Got 12.9 coming in. Let's get it more like around 12. There it is, 12.6. That's not bad. I like that rotor. It's nice. Almost as nice as my PCBWay rotor. I love that clear acrylic stuff. Anyway, let me try a couple more coils. And then I forgot what I wanted to do. Oh yeah, I want to do the SuperCat. So stay tuned. I haven't used this coil in years. I made this years ago. And it's doing really well. I can't believe it. Yeah, I have to hold it like this. Let me get you guys better acquainted with this puppy right here. Yeah, this is the... Oh, damn! Oh, no! Well, you guys saw that on film. Oh, man. That ain't good. That was stupid. Thank God I got the longer arms, but now I got to find the magnets. Oh, man, I knocked all my stuff off of there, too. Didn't hurt my PCBWay sign, though. Thank God. Oh, that was so stupid. I don't know what I was thinking of. See, that was stupid. All right. I don't know if I'm going to keep this in the video or not. I should. Damn, that was stupid. All right, let me shut this off. Okay. Oh, man. So it busted two of them. I can reprint two of them. I got to see if I could find the magnets. It looks like it shot and it went. Oh, yeah, here they are right here. All right, so they're both right here. Here are the magnets. Oh, they didn't break either. Wow, that's a miracle. And these are N52, so they're going to be really hard to get apart. Put that one there. Put that one there. Well, I found the magnets, which is good. I don't know where the circuit or the coil went. The coil must be right on the other side over there. All right, so that's enough excitement for one day. Yeah. Damn. This freaking rotor was doing so good, too. I gotta move this, too. This is a hazard waiting to happen. All these wires. It is a hazard waiting to happen. I've gotten them tangled before, too. Oh, man. Looks like I'm going to have to reprint. I don't know if it damaged the other ones. I don't think it did. No, it didn't. It didn't damage the whole thing, just these. And these, I just unscrew these. And they're basically press fit. I don't even need to really unscrew anything. All right. That's about enough excitement for today. Thanks for watching, guys. Later. So I found the coil. It's completely destroyed. I could probably salvage it, and maybe I will. I don't know if any of the wires, well, let me check. Let's get the old multimeter and see if we have any shorts. I mean, it's probably not gonna show me anyway. Oh, come on, man. All right, actually, I don't want to use this multimeter. This thing's a pain in the ass. I mean, it's a good multimeter, don't get me wrong. Gocha Fit, but this is the guy I use for all of my normal stuff that I want to just check. Let's see if we have any continuity. If we have any. That's good. That's good. No short there. No short there. No short there. No short there. All right, so it looks like it's okay. So I could probably salvage it. I'd have to put it in a vise and then pour resin all over it or glue or something. Because it's a good coil. I barely use it. It's funny, the whole thing came apart, but these things stayed on. The inside of it's really destroyed. Oh, sorry, you guys weren't even seeing it. Let me. Yeah. This thing stayed on, but the coil itself is completely exploded. But it still works. It's still good. I could probably salvage this. I'm going to salvage it. I'll put a couple clamps on there and then just dump resin all over it, or crazy glue or something. I don't know. But man, that's not the first time that something like that's happened to me. I had a Newman motor explode on me. Hey, you want to go swimming? You got to go in the deep end, baby. No, I'm kidding. I should have been much more careful. But thank God the magnets didn't explode. I didn't lose any teeth. I didn't lose my eyeballs. I'm definitely going to reprint these right now. And I'm going to fix this guy. I wonder if I can get PCBWay to print me copper, a copper coil that I can wind. They print almost anything. I don't know if they do copper. I could make it out of aluminum. I'd rather do it out of copper, though. Anyway, I'm thinking out loud. Again, thank you PCBWay for sponsoring this project video. You guys do a great job as always. Yeah, thank you. Whoa, that was crazy. That was crazy. Man, I'm really lucky that it was going this way. And when I hit it, it caught the yeah, you can see right here, it caught it right in there. Let me get this up so you can see. It caught it right in there like that and flew it that way. If it had been any other direction, like if I had been, well, no, thank God I pulled it this way. If I did it this way and got it going and it caught it, I wouldn't be talking to you right now. I'd have some teeth sitting inside this coil. But yeah, let me reprint this guy. I don't think I'm going to do it in different. I'll do it in orange and black like I always do. Not like I always do, but to match this guy. Where's that PCB rotor that I had? Hold on a second. I've got to come over here. And here's that killer PCB rotor that I just got. I really like this. I'm going to play around some more with this because I got to take this other guy down because I've got to reprint those arms. And this guy's not going to explode on me because it's a press fit, and it's also the magnets are all attracted. I mean, it still could fly out if I had it going at like 20,000 RPM. But yeah, I'm going to bring this guy back on the stand and play with him a little bit more. But again, PCBWay, beautiful job, guys. Beautiful job. Thank you, as always. Well, that was fun. All right, guys, thanks for watching. Ciao.